6, surface area of a sphere of the grade 9 academic course. So today we're going to learn a surface area formula just specifically for spheres, and you're going to use it looking for not just for surface area but also for the other dimensions. And just a quick thing, because we've been talking about surface area, and with a sphere, the idea of surface area versus just plane area. Usually when we talk about area, say of a circle, we say pi r squared, right? And that would mean, that's like the cross-sectional area. In other words, if you had a sphere like an orange, right? You had a sphere like an orange, and you cut it in half, this would be the cross-sectional area. That'd be the pi r squared. However, if you unpeeled an orange and you took all the peels and laid them flat, okay, and then measured that area, that would be the surface area of the sphere, of the orange itself. Okay, so if you the surface area is the area of the peel, and the cross-sectional area is if you cut it in half in the face, and so this is pi r squared, and this is going to be our new formula. And it's not a very hard formula to use at all. It's just 4 pi r squared. Okay, so the only dimension we need to worry about is the radius, and in the equation is just 4 pi r squared to find the surface area of a sphere, and you would have that on your formula sheet. Okay, so just a quick, using that equation then, the radius of a basketball is 15 centimeters, find its surface area. Quite simply, just plug in 15, you solve. Make sure your answer is in centimeters squared, because area is always squared whatever it is, and that's it. Easy. Here's a harder one, only because, well, for a few reasons. One is that we're using scientific notation, and you might not remember that, but we did do scientific notation at the beginning of the year. And from your point of view, really right now, all you need to be really competent at is putting it in your calculator. Okay, that's really, because we're not talking about exponents right now. We are talking about the surface area of Pluto, though, and the radius of Pluto. And we know Pluto is smaller, so by the way, as you go to answer your question, if you end up with your answer ends up being bigger than 6371, then you know you didn't get a good answer. In physics, that's something we talk about all the time, right? When you get an answer in physics, it should have meaning. In math, sometimes the answers don't have meaning, but this one sure does. Okay, so we're going to calculate Pluto's radius, and we're going to say afterwards, hopefully we can say it's significantly smaller than Earth's, because it looks to me, if that's Pluto and that's Earth, that's significantly smaller. Okay, so just looking at the stuff that we know, here's the surface area, here's the radius, apply the formula. I forgot to write it down, but you know its surface area equals 4 pi r squared, should be right there. And then I just sub in. So here's the surface area, 4 pi r squared, so r is what we're looking for. Just to solve it properly, you want to get r by itself is our goal, to get r by itself, so we divide both sides by 4 pi. You end up with a, here I just flipped it so r was on the side, but this number here, you should put it in your calculator, but this number here is equal to, what's that, 1,329,617, and then you find the square root of that to find r, and it's 1153, which, right away I know that I didn't make a mistake, because it's significantly smaller than Earth's, but it's not like it's 10 kilometers or something either. It's still a big number, but much smaller than Earth, which is what I'd expect. Okay, that's it for surface area of a sphere. So that's a wrap. 4-minute video.